Welcome. My name is Bill Phillips. I'm the Commodore of the Corinthians for 2022. And we are so happy to see so many people here tonight. We have big plans for next year, and I think everybody is going to have a chance to join in on that. I see a group of folks from the Sea Scouts, and I saw some people join on Zoom from Pelican Yacht Club, and that shows one of the things that we're trying to do. We hope to be collaborating in a big way with all the clubs and all the sailing associations out there and offering them some activities that they can join in that the Corinthians do. So we're working hard next year. Our goal is to get as many folks on the water as we can. And that collaborating with sailing clubs is going to be great. We're going to offer lots of races on the North Shore. I know we have 19. We're going to be offering 4 cruises. Now that's something new that y'all can participate in. And we're going to have 12 of these. We have mapped it out, or mapping it out, where we will have 12 different seminars this year, and they're all going to be great. I have a survey. Somebody has a list. I have a survey that we're passing around, and it talks about seminars. It has a list of about 20 different seminars that we could do next year or even in 23. And I want you to rate them for us so that we will know which ones you're most interested in. I like all of them. So anyway, I appreciate you doing that. You're going to find that the Corinthians is the least expensive and the best way to get out on the water. Our associate membership fee is only $50. And if you don't have a boat that you want to get out there and race, you can be an associate member for only $50. And you can have all of these things that are going to teach you how to sail, put you on the water. You can crew with us on races. You can crew with us on cruises. It'll be a great opportunity. So I'd strongly encourage you for that small fee to consider joining us. If you have a boat and you want to race, then jump in at the full membership, 125. Come on, 125 a year. That's it. You can't beat that. Now, I'm going to say it is really my pleasure now to introduce my friend, my treasurer on the Corinthians, my lead on all the seminars in 2022, Skipper Chenault. Stand up, Skipper. Save the big applause for the end, because he's going to deserve it, trust me. You want to know about Skipper? He's a lifelong sailor. He joined the U.S. Naval Academy, and I'm looking at his resume. I think the only reason he joined was so he could sail. He immediately joined their sailing programs. He was sailing 420s. He was sailing their big wooden, true? No, okay, metal Navy 44-foot yawl. And then he was the skipper of a 58-foot Sparkman and Stevens aluminum sloop. I mean, that's a big name in naval architecture. And he raced that boat in the Newport Bermuda race. So he's got some credentials. They did make him do some real work. So for about 7 years there, he was a nuclear submarine officer. Unfortunately, he had to do a little work, but he always got to come back to his sailing. And he did things like was in charge of the sailing training courses in the Bahamas and Bermuda. I want to do this. 22-day transatlantic crossing from Bermuda. Oh my God. He's worked as a maritime lawyer and owns one of the prettiest boats on Lake Pontchartrain. If you hadn't seen it, it's a Hershoff ketch, and its name is Ondine, and you'll see it out there. It's a beautiful boat, and it shows up at the Wooden Boat Festival. And so, without further ado, please, let's welcome Skipper.
Thanks, everybody. I appreciate it. Bill, thank you for the introduction. I want to thank Court Richardson and Pontchartrain Yacht Club for working with us for getting this seminar program started. Bill, talk with you a little bit about what the Corinthians do. We don't have a yacht club, but we have an active sailing program. But a whole bunch of our members are also members of yacht clubs. So if you're interested in the sailing program, the yacht clubs have got stuff to offer that we don't. And what the really good combination is to be a member of a yacht club and a member of Corinthians at the same time. But if you're just getting started and you're not sure, join us, get to meet folks at the yacht clubs, get to see what you do, and decide what is best for you. We've had a great working relation with Pontchartrain for many years. And we thank you for hosting this meeting for us tonight. So a little bit about what we're doing this year with these seminars is the first time that we've ever done this. This is part of what our bylaws call for. We're supposed to have a training department and do things like this, but it's never really gotten off the road. And part of the reason for that is because we've had a whole bunch of members before, and we didn't think that we needed to do this. But membership has been dwindling. Sailing across the United States has been dwindling. And for those of us who really enjoy doing this, we would like to see new people come in. Well, first of all, because I can't understand why anyone would not want to do this. And second, what we want to do is have experienced folks share the stuff that they know with new people coming in so that new people won't be intimidated by sailing, which really is a very easy thing to do, and we'll get out, get on boats, and have fun. So the whole purpose of this program is to share information with all of you that are new to it and all of you who are senior people to encourage you to take new people on board your boats when you're sailing, both for racing and for just going out to do sails. One of the things that we talked about this year, and Dave Bulliard, our local sailmaker on the North Shore, brought up, was let's have a cruising division in Corinthians. And we talked about that and thought this was a great idea because we understand that there are a lot of people that want to get involved in sailing, but they're not yet ready to do sailboat racing. And there's a whole bunch of people that go through their whole lives and never race sailboats. So we don't want racing the sailboat to be an impediment to getting you out on the water and doing stuff. And the kind of fun that you can have is just in November, we went with Wind Nuts on and my boat on a cruise that left here and went all the way down to Horn Island and came back.
Went to the islands.
We went to the islands. We had a great time. It was loads of fun. And every time you do something, at least every time I do something like that, it's a new experience. So what we're trying to do this year is to have a quarterly cruise somewhere, not go out to the islands this year, but the first thing we're planning to do is have a short cruise that goes from here over to Madisonville. Madisonville is a good place to have a cruise to because it's accessible by land for people who don't want to sail over. You can get off the boat, go home if you want, stay on the boat, and there are restaurants and things to do. So it makes it a very easy trip. For training, you get to go through the bridge. So you get to figure out what the problems with that are. You get to talk on the radio and do those kinds of things. So that's what our introductory cruise is going to be. So what we're going to do tonight is just talk about basic sailing and sail trim. And this is not aimed at the racing sailor. This is aimed at those of you that are just getting into it. And hopefully we're going to touch on points that will be useful stuff to everybody. So let's get, does anyone have any questions about anything before we get started? So before we actually get involved in the program, I want to remind everybody to mute your microphones if you're listening to this on Zoom so that we don't get noise back in to everybody who's listening. If you're here, probably turn the speaker off. Turn your cell phones off on your phones, which will be less interruption to everybody. So the objectives of what we're talking about tonight are to be familiar with some of the standard sailing terms, and to understand basic sail trim principles. And what I have here is a list of some of the references that I looked at and that I think are good sources for people who are interested in finding out more about sailing. This little book, The Craft of Sail, I had seen this before. Bill loaned me this copy of it that he has, and it's a very interesting book. It's small. You can buy it on eBay or Amazon used if you don't want to spend a lot of money for it, but it goes through a whole bunch of different things, basic stuff about all kinds of aspects about sailing. The Elements of Seamanship is a little book, a paper book.
Hey, Skipper, I hate to interrupt, but we can't hear you on Zoom.
There we go.
Okay, thank you.
All right,
Sorry.
thank you. Hopefully that's better. Anyway, you can find all kinds of stuff on the internet. If you want to dive into a specific aspect, you can find all sorts of things, weed through it, and figure out what's good for you and what's not. So don't forget that that's out there. But one of the best things that you can do is talk to people who have done that before, and they can tell you what they have done, what's worked for them. So next is, you might not be able to read the top of this. It says, know the names of things and use them. And what I wrote down here is on a weekend sail in light wind, you're having a couple of beers or something like that. The names of things don't matter. But if you get caught in a squall or a squall's coming up, you don't want to go to your crew and say, hey, pull on that rope, but let that string over there go. You have to know the names of stuff if you want it to work right. I remember sailing with a friend of mine on a J22 who refused to call anything by its name. So we got the chute up with a pole, not an asymmetrical chute, and we're going into the jibe mark, and he says, ease that rope, tighten that rope. And like, what are you talking about? You could call ease the guy, take in on the sheet, ease the topping lift. If you don't call the things by the right names, people aren't going to know what they're doing. And you say, well, I don't want to be racing. I don't just want to go out cruising. You still need to know that, and you still need to know good sail trim. Because if you get out there cruising and the squall's coming, it would be really nice if you can make your boat perform reasonably well and go as fast as it should be going normally in those circumstances, rather than just sitting there letting the squall overtake you. When I was a submarine guy, we had a whole book that told us what to call everything on the ship, basically. Not every particular thing, but there were names for everybody, and everybody used the standard names. And the reason for that was if things started getting excited and there's noise and commotion going on, and we had an air breathing apparatus, so that we're talking like this, then everybody knew what the word was supposed to be. So if you heard part of it, you knew what that word was, because that's what everybody called that thing. And people didn't just randomly make up names in the middle of something going on. So I think it's really important to know the names of things and to call things by their names. And so in the handout, I put a couple of little pictures of boats with their names of stuff on it. The paper handout, you can't read it that well, but you can see it on the one that you can download from. And then I have another one here. I'm going to leave the names of stuff and what you call to them as your homework for tonight. Even though I think it's very important, I don't want to go through all of that tonight because it's something that's so readily available to everybody. You can just look it up and learn that stuff on your own. So now what we're going to do is move on to a basic concept, which is points of sail. You need to know the different points of sail on the boat, and you need to know how the sails are going to be trimmed on each point of sail. And I'm surprised when I'm sailing with people in races that don't realize where the sails are going to be trimmed when we round the mark or on the reaching leg. It's like, is that going to be a spinnaker leg, or is that going to be, we're going to be in a close reach? It's like people don't understand that idea, but this is a really important thing to know where the wind's going to blow when you change courses and what the sails are going to do. So the basic stuff to take away from this is names of things. When the sailboat won't go directly into the wind. You've got to go about 45 degrees either side. Straight into the wind, you'll end up in what's called irons, which means that the wind's blowing straight in the front of the boat and it's not going to go anywhere. If you come off to as close as you can sail, that's called close haul. This is what you do when you're tacking. If you come off of close haul, then you're on a close reach. My boat, which is a ketch, really goes good on a close reach. Then as you come off the wind a little bit more, you're beam reaching, then broad reaching, and then finally running dead downwind. It's important to have this in your mind. And also the names. Over here, it says if you go from a beam reach to close haul, the boat's heading up. And if you're going to beam reach down to broad reaching, you're going down. So if I'm talking to a helmsman and I say, you need to come up a little bit, either to go around a crab trap or something like that, the helmsman knows that means I turn the wheel in the wind direction so that the boat goes to windward. Or if I say come down to go below that crab trap, he knows to turn the wheel in the down direction. But that's a basic thing that's very important, that everyone needs to know these kinds of things. And another thing from a safety point of view, from points of sail, I want to emphasize the dead downwind thing. The thing, I'm not afraid of too many things on sailboats, but what I am really afraid of is going dead downwind with people who do not know that they're about to jibe the boat. If you've got a boat, a big boat with a boom that's fairly low, you're not going to survive a whole lot of times of getting hit in the head with a boom from when someone accidentally jibes. So by knowing the points of sail, becoming familiar with how the boat behaves in each of those, you'll be careful when you're going dead downwind, and you may not sail dead downwind, you may sail to one side or the other on a broad reach, but you won't do things like accidentally jibe the boat because you're going to be aware of where the wind is coming from. Any questions about that? Now, let me go back to this previous one. This is points of sail. If you've been on a boat before, you know that the boat goes faster as we get off of a close haul and then gets on to the reaching area. This is the fastest points of sail, and dead downwind is a little bit slower. Naval architects and yacht designers can predict the boat's speed on those different points of sail. And this next slide shows polar diagrams, polar prediction diagrams. And what this shows is speed coming out from the center here and true wind angles. So when you're going close haul, you'll see that there's an optimum point that you can go close on the wind, and then it starts dropping off. So those people who do what's called pinching in a boat, they've sailed more upwind from this optimum point. And so while they may be going a few more degrees to windward, their boat speed's now dropping off a whole bunch. The same thing happens going dead downwind. As you can see, the speed starts reducing on the boat as you go dead downwind. And this curve right here is the speed of the fastest boat speed in the direction of going downwind. So if I'm going at this angle in light air to the wind, which is 10, 20, 30, 40 degrees, 42 degrees off of dead downwind, my boat's going faster through the water and making more distance in the direction of dead downwind than a person who's actually going dead downwind. This also is going to vary from boat to boat, what sail combinations you have. This drawing on this side shows these cutoff points where you've reached the maximum speed, and even if you can sail the boat over here, it's not going faster. You're losing ground to someone who is sailing over here. Does anybody have any questions about this? Yes, David.
Why is it called a polar?
It is called a polar diagram because of the type of graph it is. This is a polar graph because it has the center of the graph at 0 right here. If you were in a trigonometry class or something like that, you'd have the whole graph. But that's the center of the graph, and then it goes out 360 degrees all around. And so this is the pole, and that's where the name comes from. It doesn't have anything to do with the North or South poles or stuff like that. But the point of this is to just show that this kind of information is available for boats in general, and for many of you for your own boats, and it shows how your boat might be expected to perform at each point of sale. Also, the new ORR rating system is based on this type of analysis, and that's why we have different handicap allowances for different wind directions and different speed directions. That is not the way that the PHRF system was set up. Another thing that I want to say is that when you're sailing your boat, you're tacking, you're changing direction to go upwind or jibing going downwind, there's a lot of things that you can do to take advantage of the boat's performance. I put this little dot in here. And let's say this is a buoy and you want to go around the buoy. Your boat has got a turning radius that it's going to turn in. A dinghy could turn in a real small one, but a bigger boat's going to need some space. And this just shows if you want to end up close to this thing down here, let's say it's a buoy, don't start turning right at the buoy. Start turning way up here and then come around so that you're close to the buoy when you end your turn. And then another thing, going to windward, if you're tacking, the idea of a good tack is not to see how fast you can throw the tiller or the wheel over and get the boat from one tack onto the other one. Because when I sailed that 58-foot boat that Bill mentioned, the boat would carry its headway a long time. So we would start here and we'd start coming up into the wind. The sails would start luffing, but they're still driving, not as much as they were before. And we would shoot the boat up to windward, cast off the jib, and then slowly come around with keeping our headway up on the other tack. And we would probably move that boat 2 boat lengths to windward just in the tack. So for a 58-foot boat, that's almost 100 feet if we went to windward. And if you think about how many times you've come, if you're racing, you've come to a mark or some obstruction, and you could use that extra 100 feet to go up. Well, if you tack so that you optimize how you go through, then you get that extra bit of distance to windward every time you tack. You can't do it as much in a laser, but in a boat that carries more headway, that's something that'll work. This also has standard terms for tacking. This says ready, well, this is the jibe side. It says ready to jibe to get everybody ready. Then jibing as it happens, say the boom coming across. This isn't the way that I learned to do it. I was told and say prepare to jibe. Then the crew says, yes, we're ready. Then I say jibe ho, and then we jibe the boat. For tacking, this is a way that you can do it, but the way that I've always done it and was taught was to say ready about, then the crew gets ready. They say they're ready, and then I say helms a lee. I turn the boat through the wind, and we tack. And if you wonder why you say helms a lee, this all comes from tiller boats, because the tiller to tack is going to be taken from the centerline position and put down to the leeward side of the boat, the downwind side of the boat. So you put your helm a lee, the boat comes through the wind, and you tack. Any questions about this slide? Another thing that I think is important to everyone understand is the relationship between true wind and apparent wind. True wind is the wind that you feel if you're stationary. But when we're on a boat and hopefully it's moving through the water, we're not feeling the true wind. We're feeling what's called the apparent wind. And the apparent wind is the vector sum of the true wind and the observer's motion. So I have a slide that, well, before I show you the slide, think about it this way. If we're standing outside, not moving, and the wind is from the north at 10 miles an hour, we're feeling the true wind. It's 10 miles an hour. If there's no wind, I'm not moving, I feel 0 miles an hour. But let's say I jump on my bicycle and I start with no wind, I start riding east at 10 miles an hour. Am I going to feel wind? Yes, I'm feeling the apparent wind, and it's going to be, I'm headed east, so I'm feeling 10 miles an hour of wind from the east. Now, what if we actually had true wind of 10 miles an hour from the east? Then when I'm riding my bicycle at 10 miles an hour, I'm going to feel the apparent wind at 20 miles an hour, because it's going to be my speed wind from the east, my generated wind from the east, plus the true wind from the east. If I go 10 miles an hour to the west, I'm not going to feel any wind on me at all, because the wind that I'm generating by moving is going to cancel out the true wind, so I don't feel anything. On a sailboat, we're almost never going directly into the wind or directly downwind, so what we end up with is a vector sum of these things, and this is what it looks like. Here we have the boat speed generating wind that goes like that. We have the true wind coming from some angle, and we get an apparent wind, which is going to be stronger than the true wind. And this is what we're going to feel on the boat, because it's a combination of the true wind and the boat speed. Now, this angle is the angle of the true wind, but because of our boat speed here, the apparent wind is going to be at a closer angle to the bow of the boat than the true wind is. Does anybody have any questions about that? Now let me show you the next one. And this is an interesting thing. Let's say that we're sailing along, we have this true wind is constant, the apparent wind is constant, boat speed is constant, and all of a sudden we get a puff of wind from the same direction that it was blowing from, but it's another 2 knots faster. What are we going to feel on the boat? Well, this vector, the true wind vector, is now longer. So and since our boat speed vector stayed the same at that instant that the wind picks up, we're now going to have the apparent wind being at a higher amount, and the apparent wind angle is going to shift slightly aft. So that means when you get that little puff of wind from the exact same direction, you're actually getting a lift that you feel on the boat. And so you can come up and sail a little bit closer on the wind. If you're out cruising, these little puffs aren't going to make much difference at all. But on a boat that's racing, that the crew is aware of this, the helmsman is aware of this, there are constant adjustments that can be made all the time to optimize these kinds of situations. The same thing, if the true wind drops off, then the apparent wind is going to drop off, and it's also going to move forward. So at that time, the helmsman, if you're tacking, beating, he's going to need to bear off a little bit to keep the boat speed up. Then as his boat speed comes up or goes down, all of these things are going to be constantly changing. The reason I'm talking about this is, again, I've been in the last few years with people on the boat who don't understand how apparent wind works and why it changes directions and stuff like that. Another thing that I wanted to tell you is we actually do vector stuff I have on a boat. I've got a little maneuvering board, I'm going to call it, because that's what we called it in the Navy. And when I was on a race course, and I would figure out what the true wind was on the course that I was on, I'd mark it on here. And the next leg, I know what the course is going to be, so I plot that on here, and I figure out what the apparent wind angle and speed is going to be on the next leg based on my estimated boat speed. What's that going to do for me? It's going to tell me what head sole I'm going to do. Am I going to use a reacher? Am I going to use a close cut spinnaker? Am I going to use a running spinnaker? And what weight material is it going to be? All of that stuff is something that you can figure out if you understand how apparent wind works in the relationship. Probably if you have the latest, greatest Brooks and Gatehouse system on your computer, on your boat, it may figure all those things out for you. But if not, there's ways that it can be done. You should just be aware of what the relationships are. Any questions about anything with apparent wind? The next thing I want to talk about is just basic sailing theory. An airfoil shape creates a low pressure that causes force to be applied to the sail.
Skipper?
Yes.
Real quick. While you were talking about puffs and lulls, could you go over for everybody what the puffs and lulls look like on the water? You know, with the
Yes.
puffs looking darker and, you know, so you were talking about it, because it'd be a nice,
Yeah, I had the fun just a couple of weeks ago to be on the committee boat for the laser regatta that happened. And what was so much fun about that is that not having to think about all the different things on a boat that are going on, I could sit there and I could watch the puffs roll in, because we had some pretty heavy weather, but you could see them. What happens is the waves on the water make the water appear at a certain shade of gray, let's say. And what happens is when you get more wind, the wind starts generating little bitty waves on the water. So there's more ripples on the water, and the water changes color. It gets darker. And so you can see these puffs moving in across the water. And then you can see areas where it's glassier, where the wind is lighter. So after you get used to it and you are able to sense more than one thing at a time, multitask while you're sailing, one of the things that you'll do is you'll watch these puffs coming in. And it's important both in light air and in heavy air. And so then you're prepared to know that you are going to get the puff. You can see angles of change in where the wind's coming from. David, you want to add anything to that?
no, that's perfect.
But this is something that you can see. The more time you spend on the water, the more you get to see what's going on out there. Yes, John.
Well, that's kind of something the skipper can't really do. That's something the crew has to look for. The skipper's kind of concentrating on sailing the boat and watching the sails and stuff like that. Crew needs to be the ones to look out on the water and pay attention to what's going on with the wind and waves and everything else. Crew needs to see what's going on. Let the skipper know what's going on.
Well, that's a very good point. Not only, it mostly applies when you're racing, but it's also an important thing on cruising. If you can get all the people with you aware of what the different things are, then you do better. In racing, I've sailed on a boat where the jib trimmer, the mainsail trimmer, the helmsman were constantly talking to each other, especially in light air working to windward. And someone's watching out and seeing puffs on the water. They say it looks like a puff's moving in. So the helmsman, the jib trimmer, and the main trimmer are all getting ready to decide what they're going to do to maximize the advantage of the puff, which may be ease some sheets, trim some sheets, but we want all of this stuff to happen the same, so that the helmsman, if he gets the increase in speed and he's got the lift, he's going to start steering the boat up. There's more wind now on the sails, so everything's going to stretch a little bit. So the sail trimmers may need to trim those sails in a little bit more. On a boat where people are doing this all the time, it almost can be done without speaking to each other. But when you first start off, people don't know that automatically. For cruising, you don't need to do that, but we're talking about this a little bit just so that you're aware of different things that go on. And that's actually one of the things that to me is a lot of fun about sailing, is that you can always get better at it. You can always learn new things that you never even thought existed. Any other questions about that?
Yeah, and let me just, and those were great questions. And let me just mention that, to make this go smoothly, we're gonna hold off on most of the questions until the very end. But if you just can't stand it, go ahead, throw it in.
So getting back to sailing theory, the sail is an airfoil shape that creates lift the same way that the wing on an airplane does. And I'm going to show you some vector diagrams about how that force is resolved into forces in different directions. But I want to point out that just as the way that the sails create lift, the keel on your boat is creating lift at the same time. And what it's doing, if you didn't have a keel on your boat, it would go sideways because of the tremendous amount of sideways force. But what the keel does is it generates lift also, and it keeps the boat from moving to sideways as much. And we'll talk about that in just a second. So this is a picture about sailing theory, and I'm going to do a little demonstration for you here to illustrate the Bernoulli principle and how the sail generates lift. This piece of paper has constant air pressure all around it, and gravity is causing it to hang down like that. The Bernoulli principle says that if I increase the speed of a fluid, water or air, any kind of fluid, it lowers the pressure on the area where you have a moving fluid. So if that's true and I can demonstrate it, then the pressure underneath, which is the same pressure in the room, will be greater than the pressure in the moving one, and this will straighten out. So watch. See, it comes up. The reason it comes up is because I've got faster moving air on this side, the air pressure down below, which is the same other pressure, moves it up. That is how the sail works. So here we have the sail, which is an airfoil. The wind moves around faster on the curve, the back side of the sail, not as fast on the front side. So it generates that force, which produces lift. It pulls the boat along. Now, here, this drawing shows that you have the total force that pulls the boat, and we can break that, an aerodynamics guy would break that into two components. He'd say, well, one is the lift component, which is perpendicular to the wind, and the other one is the drag component, which is in the same direction as the wind. That's not as important to us. We're going to take that same force, and we're going to look at it two different ways, and we're going to see that it gives us a little bit of force in the direction of the center line of the boat, and a whole lot of force sideways, which causes the boat to heel and to slip sideways if you didn't have the keel there to keep it from going. So in your mind, keep in mind that you have those different forces, and that's what the sail is doing. The sail is generating lift. So for sail trim, what we want to do is optimize the sail, the shape of the sail, and the interaction between the main and the mizzen, just so that we can get the optimum force that's available. Here's another picture of the wind coming, drag force in the direction of the wind, lift force perpendicular to it. But I like this drawing because it showed the boat speed going this direction, not along the center line of the boat. And that's because the boat is drifting sideways slightly from these side forces, the heeling force and not the drive force. There's an angle here that would be, you could call it the drift angle. And typically for a sailboat, this is about 5 degrees. So when you do this perfect tack on your boat, you look down the center line of the boat and it's perfectly aimed at the mark or whatever that you want to go around. If you want to go to windward of it, if you haven't taken into the fact that you're going to slide sideways about 5 degrees, you're going to end up going behind it. When you are looking on the boat, the heading will be what the compass course says. But the course over the ground, your GPS course, is going to be this course right here. So when I'm planning stuff on a boat, I take into account that I'm probably going to have 5 degrees of sideways slide on courses, and that's just something to plan for. Any questions about that? Next thing I want to talk about is how a boat gets balanced. And we'll first talk about the picture that's here on the left. This is a typical sailboat, a keel kind of like mine. It's not a very efficient keel. And there's some centers that I want to talk about. We've got the mainsail right here, and the mainsail has got a geometric center of it. We're going to call that the center of effort of the mainsail. If you were an engineer and you wanted to simplify this drawing, this point would be where the force generated by the mainsail works. This is the center of effort of the fore triangle or the jib. So that's where the force of the jib would work on the boat, pull the boat. The center here is the total center of effort, and that's the combined place that both of those sails are working. To counteract the center of effort, which is also going to pull the boat sideways with the heeling force, we have the underwater body of the keel, and it has a point called the center of lateral resistance. The center of lateral resistance is a place where if you tied a rope onto the side of the boat above the center of lateral resistance, you could pull it sideways and it would just stay perfectly sideways. So to make a boat balance, what we want to do is to line the center of effort of the sails up almost with the center of lateral resistance. But the center of effort for the sails has got to be a little bit forward of the center of lateral resistance to account for bow waves and other things. So this little distance between the two of them is called the lead. And a naval architect or yacht designer is going to design the sail area of a boat so that he has what he thinks is the right amount of lead for the sail plan that he's designed for the boat. Now, when you're sailing dinghies like the Flying Scot, it's one of the boats where you can do quite a lot to move the centerboard forward and aft, up and down. And what that's doing is it's moving the center of lateral resistance back and forth underneath the boat while you're sailing the boat to optimize the performance of the boat. I put this up here. This is a J boat that's been made into a wind vane. If the rotation point for the wind vane was at the center of lateral resistance of the real boat, it wouldn't work as a wind vane. So to make this work as a wind vane and to point into the wind, you have to move the wind vane center of lateral resistance forward of the center of effort of the sail plan. So it's all a balancing thing. Right. And what we were talking about was center of lateral resistance and center of effort and how those two balance over each other so that the boat either goes to windward the way that you want it to. If I back up one and go back to this, if the center of effort were moved aft here, then the boat would tend to sail up into the wind. And so what you'd have to do, it'd be pull on the tiller to make the boat go downwind and be balanced. And since I'm pulling the tiller to weather, that's called weather helm. If the center of effort of the sail were moved back behind the center of lateral resistance, then the boat would tend to go downwind. So I'd have to push the tiller away. That would be lee helm. So what you do when so the naval architect's going to try and balance these things out so that the rudder or tiller is in the middle when you're sailing to windward with your sails up. Now, here's the same picture, but I've modified it a little bit to talk about different situations. First of all, in this one, let's forget that the jib's even there at all. I'm sailing with just the main. So what's going to happen is my center of effort is going to be just the center of effort of main. It's going to be behind the center of lateral resistance, so the boat's going to tend to round up into the wind. So you'll have weather helm, so you'll have to pull on the tiller or steer down to make the boat sail, but the boat will sail reasonably well like this. If you haven't sailed your boat with just the main, you ought to practice doing that, because this is the best way if you're coming in to an anchorage to anchor or to go pick up a mooring. If it's a place that has a mooring, you want to have just one sail that you need to worry about. That way, if you come in like close hauled to a thing, you can ease the main off till it luffs, the boat will slow down, you pull the main in, and you can adjust your speed real easy. You know what your headway is because you've practiced this, and then when you want to stop the boat, you just shoot it up into the wind, and everything starts luffing and the boat stops. If we're doing just the jib, the center of effort now is just the jib center of effort, so it's way forward to the center of lateral resistance. So that's going to make the bow tend to go down. So you're going to have to push the tiller away or steer up into the wind to balance the boat out. You can sail with the jib. You see people all the time sailing on the lake out here where they've got roller furling jib. They've gone out, they don't bother with the main, they just unfurl a jib and they sail all afternoon. That can be a real pleasant thing, but it's not going to be good for going to windward. And it's going to be really difficult if you're trying to maneuver the boat in a close place with the jib. Because it'll always be blowing the bow down and you'll get into trouble. Now, let me finally talk about reefing. If we reef the main, it's going to reduce the sail area in the main. It's also So there's going to be less force acting on it. Not only that, but the center of effort of the main is going to be moved down. If you have the full jib up, then the combined center of effort is also going to be moved down. It's also going to be moved forward. So reef in the main is going to do two things. There's going to be less heeling force on the sail. There's going to be less weather helm because the center of effort is going to move forward, and you won't be fighting the rudder as much. So the boat speed will probably go up. The traditional thing is if you're thinking about whether you need to reef the main, you've already probably passed the spot where you should have. And a year ago on Albert's boat, Catalina 30, in Lake Bourne, another trip out to the islands, the wind just unexpectedly picked up quite a bit. We reefed the main and probably got a half a knot or a knot more speed, and the boat was just perfectly balanced, and we went on our way. So it really made a difference. Any questions about this? All right. So now that we've talked about those basic sail tank principles, I want to talk about sail trim, and the way that I thought to go through this would be how you set the sails on just your basic sloop with Dacron sails. So the first thing that I'm going to do is set the mainsail because it's in the back of the boat, and that way the boat will stay pointed into the wind so that I can control it better. I'm going to set the outhaul tension, and I'm going to ease the boom vang, which would hold the boom down. I'm going to ease the main sheet out completely so that the boom is free to move around as I pull the sail up. And I'm going to clear any running backstays. Boats with running backstays, the running backstays can get caught on the sail as it goes up, which, if you're not paying attention, can result in you tearing your sail or doing something to the running backstay. What I'm going to do is I'm going to also tighten the permanent backstay for the expected conditions. Usually people will ease off the permanent backstays if they have an adjustable backstay, but I'm going to set it to some amount of tension that I think is probably right for that day. I'm going to adjust it later, and we'll talk about that. Then I'm going to head the boat into the wind and let it stop or slow down so that I don't have all kinds of wind, and I'm going to hoist the main to the normal place that I hoisted. I don't know what the normal place on your boat is. Once upon a time, in the days of IOR handicap system, we had a black line on the top of the mast, and you would hoist the sail up to that mark, and then you would adjust it after that. BHRF doesn't have any kind of mark like that. Class boats may have it, I'm not sure, but you're going to raise the main to where you normally raise it, and then stop. You're going to make sure also that the topping lift is loose. I see boats a lot of times where the topping lift is tight, and so it's lifting the end of the boom up, and so the main is in some goofy shape because you can't trim it using the boom because you've pulled up on the boom with the topping lift. So make sure the topping lift is loose. Then I'm going to fall off. I haven't raised the jib. I'm going to not be head to wind anymore. I'm going to come off in one direction or the other, direction I want to be on, so the boat isn't sitting there in irons, unable to be maneuvered. So coming off a little bit, I'll start to make a little way sailing, and I've got control over the boat. The next thing I'm going to do is trim the main as appropriate for that point of sail, just to get the boat moving. But I'm not going to, I may take slack out of the boom vang, but I'm not going to tighten it yet. And then I wrote down here, practice sailing without the main. If you haven't sailed your boat with the main, without the jib, if you haven't practiced sailing your boat with just the main, you really ought to do so, because there are going to be times where you want to sail the boat with just the main, and that way you won't be surprised. You'll probably be surprised how well the boat sails with only the main, and it won't be a new thing if you ever have to use it. So now that we got the boat up, it's off on some tack just a little bit, it's barely moving along, then we're going to go up and we're going to set the jib. And this is not a roller furling jib. After I wrote this, I thought, oh, heck, if you got a roller furling jib, you just pull on the jib sheet and boom, like a blind's opening up, there's the jib. But this is the other stuff, you don't have that. You make sure that the jib is on the proper side of the boat, If the boat's going to fall off on a port tack, it's real nice to have the jib on the port side of the boat so that when you raise it, it's not beating you up forward by the mast, coming from the starboard side as the wind catches it, blowing across the boat. You make sure that all the sheets are eased. You hoist the jib and tighten the halyard till wrinkles start along the luff. This is with what I've done with Dacron sails. If I have a low stretch fabric, this may not be the way that I'm doing it. But what's going to happen is I want to make sure I have enough tension in the halyard. It's easier to ease a halyard than it is to tighten it once the boat starts sailing. So on my boat, I tighten it till I just start to get a little bit of pull along the luff, the forward part of the sail. And then I stop there. Then I sheet in the jib. And what's going to happen when I sheet in the jib? Well, first let me back up. Sail material stretches. The material itself does, and then depending upon which way we put the force in the sail, it's going to stretch more. So as I've pulled it tight with the halyard, so I've got a little bit of stretch in it. And then when I tighten the sheet, it's going to pull in a different direction. So that's going to counteract that extra tension that I had there. And what I'm hoping to have.
Upcoming violation, 14-hour workday limit.
What I hope that's going to do is then give me a good even sail shape. So I'm going to sheet in the jib and trim it for the desired head. And then I say, here, sometime practice sailing with only the jib so that you know what the boat does with that. So now I've got the sails up, the boat's moving, and now I go back and I look at everything again to trim it. And I'm going to start with the jib. I've got the jib up, but now I want to, I've basically trimmed them. I want to go up to the bow, and I'm going to look at the headstay sag to see whether I've got my backstay tension right. If it's light wind, I expect to have a little bit of curve in the headstay. I expect it to sag off a little bit because the sails cut with a little bit of curve, I think, for the headstay, or some sails are. And if you pull them completely tight in light air, you're going to mess up the way the draft is in the sail. The position of the maximum draft should be about 45% back from the luff of the sail. So a little bit forward of the middle of the sail is where your draft is. If it's way far forward or way far back, the sail's not adjusted right, and so you'll need to adjust it more. If I need to take more halyard tension, I need to ease the sheets off before I do that because there's too much friction in the sail and too much load on it to be able to tighten the halyard. If I need to ease the halyard because I've got the draft too far forwards, then I can ease it off just a little bit. The leech should probably be a few inches off the shrouds, where the leech comes across the shrouds. And this is something that you'll have to figure out for your boat. It's going to be different with different boats. I've sailed on boats where what we've done on the spreaders is we've wrapped tape around the spreaders so that you can see the distance that the sail is off the spreader and gauge it by the marks that I've put on the spreader. What we want to get is that sail to have a good airfoil shape with the draft about just a little bit forward to the center. And then what we also want to do is have it a uniform shape all the way along the luff. And the way that we tell that is all of the telltales at the bottom, middle, and top of the sail should show a luff starting at the same time. If they don't, it means that the sheet lead position should be changed fore or aft to make that work. And I have a slide that shows that. So if the upper telltales start to luff before the lower ones, that means that the sail's too far out at the top of the sail already. So what I need to do is to do something to the sail to pull the top in while keeping the rest of it. And if I pull the top in, it's going to let the bottom out. And so I want to adjust it, pull the top in or let the bottom out till I get them all the same. And this next slide shows how that's kind of going to work. So in this picture right here, we're looking at the sail from the windward side of the boat. So this sail's out on the starboard side, we're standing on the port side. You can see that the foot of the sail is curved a lot here, but the leech of the sail is real tight. So that means that the bottom is luffing before the top does. This sail has got the foot pulled really tight, and so the top's going to luff before the bottom does. This sail has the jib lead way far forward on the track that goes on the deck. This one has it too far aft, so what I do is I put it in a middle position so that these telltales along here all luff at the same time. This bottom picture shows the same thing, but it actually shows the telltales on the sail. It just wasn't as good, in my mind, as showing the slack leech and slack foot as this other one. So I put both pictures on there so that you could see it. But the idea is to move the sheet lead forward or aft so that you get uniform flow across the sail. Because we want to, you don't see too many airplane wings that curve different angles along the edge of the wing. It's pretty much a uniform thing. So we want the jib to be like that also and have the same, have it luff at the top, the same time it luffs it at the bottom, as a general rule. This is a picture that I saw on some sailmaker's website that showed the forestay sag. It says, this is good light weather trim. They're sagging the forestay to give the headsail a full, powerful shape. So here you can see the shape of the sail. You can see that the draft of the sail is close to the middle or a little bit forward, but he's got the headstay sagged off a little bit because it's light air, and that adds to the curvature that's in the sail. So now that we got the jib set up, we're going to move back to the main. And unlike the jib, which is trimmed from the luff, the main is trimmed from the leech. This is the way I've been told to do it for many years, and it makes sense to me. So like the jib, the center of the draft should be about 45 degrees aft from the luff. And we do that, move it by adjusting halyard tension or the Cunningham, which is a line that goes through a hole in the sail up by the gooseneck and down to pull the sail down right above the boom and stretch it close to the mast. The name Cunningham comes from Briggs Cunningham, who was a race car driver and also a 12-meter skipper back in the 60s. And I guess he invented that thing, and it's got his name. So we want a large draft in the sail for light winds, and we want to remove the draft for stronger winds. The outhaul in the sail is very important, but it's only going to adjust the bottom third or so of the sail. So if it's windy, we want to tighten the outhaul. If it's a not so windy day, we want to loosen the outhaul. Tightening the Cunningham line will move the draft forward. And the other thing, if we still have too much draft in the sail and you have a mast that's kind of a bendy mast, increasing the backstay tension will bow the mast forward, which then stretches the middle of the sail and removes some of the draft. A lot of cruising boats have a mast that is not supposed to bend at all. So increasing the backstay tension is not going to have that much effect necessarily on the mainsail, but what it's going to do is it's going to change the shape of the jib. It's going to pull the draft, it's going to tighten that headstay that we looked at in the other picture, which is going to move the draft. And then on both sails, I put down at the bottom, adjust the leech line if needed. The leech line is a line that the sailmaker puts in the back of the sail, and what happens is it keeps the back of the sail from fluttering as the sail stretches or things happen. So if the back of your sail is fluttering, either the main or the mizzen, find the leech line and pull it until that flutter stops. If you pull it too much, and so the windier the day is, you may have to put more tension on it. I see a lot of people with the leech lines really tight, so the back of their sail, instead of being a smooth thing for the air to come off, it's cooked like this. And so that's a good way to go really slow. So pay attention to your leech line. So after we touch the draft, adjust the draft in the sail, then the big thing for the main is to adjust the amount of twist that's in the leech. And the starting point of this for adjusting leech, the twist is to have the upper batten in the sail parallel to the boom. That is a good point to start. This, I think, is an important point. On boats with a traveler, the main sheet primarily adjusts the twist because it's pulling straight down on the boom. The traveler adjusts the angle of the sail in and out. And I've got this next picture, which, well, first of all, this one shows the draft in the mainsail, some twist going up. There's the center of the draft. It's slightly forward of the middle of the sail, which is probably where this seam comes up. It says this mainsail is set for medium to heavy conditions. The backstay is tight, which straightens the forestay or headstay and flattens the entry of that sail. The general cars have been moved aft to twist off the upper part of the leech because it's a windy day. Now, yes.
Excuse me. That means that that photo is a good setting or it's bad?
This came from a sailmaker's website, and he thought this was a good setting for the mainsail under these heavy conditions on that boat.
Okay,
Yes.
and the yellow is the draft.
Yeah, so this sail has got a speed stripe, or whatever you want to call it, the line that goes through to help you visualize the draft. The yellow line is a straight line taken from the mast to the leech of the sail, so that you can see how much draft is in the sail and where the center of it is. My friend Tim on his J35 has got a mainsail that has a picture of the camera right in the center of the boom on the sail, and it says, "Take picture here." And that was kind of a joke on the boat, but the sailmaker put that there so that if you wanted to interact with the person and discuss what your sail looked like, that's the spot to take the picture, looking up the sail, so that the sailmaker, who's not on the boat, can see where the draft is located, what the leech looks like, and all of that kind of stuff. So to evaluate the draft in the sail, you probably want to be in the center of the boom to look at it like that. Any other questions? So the next thing is how to get the leech of the main, the twist in the main. On the jib, we had telltales along the luff of the jib. The most important telltales on the mainsail are the ones that are on the leech. And what you want to have is most of the time the flow coming off straight, so that these telltales are going back and they're not curving around to the other side. And for the amount of twist in the sail, the top one, we want to have the top batten, which is up here, more or less parallel with the boom. Now, changing the twist in the sail is you want the leech tight if you're going to windward. If you want more power in the sail or you're in light area, then you want to have more twist in the sail. But that is for a more advanced lecture than this one or seminar. This slide I put in here to show how the mainsail twist is adjusted by the main sheet, by pulling down. Pulling down takes this twist out of the sail and makes it look more like that. So if you have a traveler, you can first adjust the twist in the main by setting the main sheet, and then you can move the traveler outboard or inboard to adjust the angle of attack of the sail so that you get the optimum performance. Boats like mine that don't have a traveler, I use the main sheet to do both of those functions. But the more efficient way is definitely to have a traveler. The boom vang is also a device for setting the twist in the mainsail. But I don't like using the boom vang to do that close hold, because what ends up happening is if I tighten the vang up, I forget that I have the vang tight, and then when I want to ease the main sheet off, either for a puff or a wind, I can't, it's not going anywhere because I've got the vang set. So when I'm working in this traveler range, I can use the main sheet to adjust the twist, and I don't need the vang. But when you get on a reach, you'll want to use the vang to adjust the twist in the sail. This is a picture that talks about the interaction between the main and the jib. And I started looking at this, and the actual stuff that goes on from an aerodynamics point of view between these two sails is pretty complex. There was a aeronautical engineer from Boeing who wrote a series of papers in the early 70s about what's going on here. And what he ended up saying was that there was a circulation that develops around these sails, and see, we have streamlines that are going all the way through, but he really said there's other, and he measured this with all kinds of things, air that's moving in different directions, and what is happening is the main's not doing so much, but it's really reinforcing the lift that's being produced on the jib. I don't know any of that, but we don't need to know the answers to that to do this. But what we want to do is we want to have a shape that's going to allow the air to flow smoothly through here and have sort of a nozzle effect between the jib and the main. Because just like when I blow over that paper, increase the speed, the flow on one side, it gives me lift, a force on the other side. We want to increase the flow through here. So this is what you want to have, and these are pictures of what you don't want to have. You don't want to have this big gap between the main and the jib, because you're not getting that nozzle effect through there. And you don't want to pinch the nozzle off, either by having the jib in too tight or the main eased out too far. This is another picture that shows that kind of effect of, this shows the effect of what the wind should, how it should flow through and stay kind of attached, is what the word that they use, to the backside of the sail, so that you have good flow and good sort of nozzle effect in here between the jib and the main. Here's a picture of everything going wrong. First of all, the angle of attack here is the way that you want it, so that nothing's luffing or you don't have the sail too tight. Here, the boat's not on the wind enough, so that you basically have the jib too tight in for the point of sail. Plus, you've got constricted flow through here on the main, and backwinds the front of the main. And what this does is it causes little whirlpools or vortexes in different places, which slows down the flow and makes the boat go slow. And then finally, this is a picture that I saw that I thought was a pretty good description of what everything should look like. For here in light winds, he has, it just shows the sail. And what I thought is interesting is the curvature of the main and the curvature of the jib kind of follow each other, so that along the whole length of the sail, you have this open slot that's funneling the air through. But then as the wind picks up, he puts more twist in the sails to develop more power. He's eased off the leech a little bit, and he's tightened the luff of the sail with the Cunningham to move the draft forward as the sail stretches. Notice in the light air that the boat is heeling a little bit. In very light air, the wind is not able to push the sailcloth out to give it the shape that you want. So you can use gravity to help you by putting weight on the boat down to the low side, so that the boat leans as much as you can get it to lean, and then gravity helps the sail go into the right shape. So in my mind, we want to make the shapes look like a good airfoil shape, and if the wind's so light that we need to use gravity to help do it, then that's what we should do. So any questions about this? We've covered a whole bunch of ground, and so we're almost done. This was almost all about sailing upwind that we've talked about. Then we talked about sailing on a reach, and I saw this term. I'd not heard this before, but it's something that I believe is true. And trimming the sail, if in doubt, let it out. Most of the time, people trim the sails in too much. So you should ease the sail until they begin to luff, and then you should tighten it in just a little bit till they stop. Now, if you're cruising, you can do this once every hour or so or whatever, depending upon how well you want the boat to perform. If you're racing, This should be probably going on all the time. It should almost never stop. It should be this coordination between the helmsman, the main sheet trimmer, and the jib trimmer, so that we're always optimizing things. Now we're sailing in a reach, so we can no longer use the main sheet pulling straight down because the boom's way over the side of the boat. So to avoid having too much twist in the main, we're going to use the boom bang to control the shape of the mainsail so that it has a good shape to it. The tails on the back are streaming out. The jib sheet leads may need to be adjusted. They probably need to come aft now because the jib is designed and the leads there for going to windward. But when you're no longer going to windward, you want to lift up the clew of the jib and move it outboard. When we race on Big J, as soon as we get off the wind, we don't use a spinnaker, so we're doing non-spinnaker. We run a short sheet, which is another sheet with a snap shackle on it, under the clew of the sail, put it to a block on the tow rail, and then go to another winch. And that way we have two sheets on the sail, and we ease the sheets and move them forward and aft so that we can try and optimize the position where you want the clew of the sail. So what I think about trimming the main, it's like, where would I want to grab the end of the boom and put it so that the shape of the main is the way that I visualize it should be, and the same with the clew of the jib. I want to move it out, I want to move it up so that I get this even sail flow over. So there's lots of things that you can do to help that out. So you move the jib sheet leads as you can and adjust it so that you try and get an even break on the sail and try and optimize the shape of the sail. And then finally, going dead downwind. Going dead downwind, the aerodynamic shape of the sail is not the thing that's moving the boat as much. It's there because it's just drag now. Remember, we had a lift and a drag component when we looked at the sail pictures in the beginning. Well, when you're going dead downwind, it's almost all drag force on the sail. But here you have a boat that has the jib on the same side as the main. And you see the jib isn't getting much air to it at all. This one is now wing and wing, and we've got the jib off on one side of the boat and the main on the other. There's still a big drag component on this, but actually we're probably generating lift over the, now starting at the leech of the sail rather than the luff, and building a little low pressure area in here, because we've now got flow that's going across the sail instead of just hitting it sideways and tumbling around the side. So finally, going back to our polar diagram, I said before that there's points in here where you're making the maximum downwind speed for your sail combination, but not going dead downwind. And if you want to maximize that speed, then you go at this angle if you're at this wind speed, and then you jibe over and you go at the same angle on the opposite side, and you tack downwind, which looks like that. Tacking downwind, what this polar diagram shows, is that at light air, the angle that you tack downwind is going to be greater. As the wind starts picking up, it's going to be a smaller angle off. And at some point, the wind gets strong enough for your boat speed that there's no point in doing it at all. Any questions about this idea? When we came back from the Gulf Coast this year in November, the wind was dying off and we weren't racing, but we tacked downwind because that way we get all the sails on the boat doing something instead of them just sitting there hanging. And it helped quite a bit. That's it. Does anybody have questions now that we can talk about? Yes.
Can you talk a little bit more about the twist? Good, bad?
The twist.
Or depend on the conditions? Yeah.
The twist is going to depend on the conditions. If you want to go to windward and point, the less twist that you have, the higher you can sail the boat into the wind. If you need more power or to sail the boat in light air, you may want to have more twist in the sails. Dave, can you add to that?
I'm sorry.
The question is what would be the thing to say about the amount of twist that you have in the sail.
Okay. On the, you did a really nice job of talking about the telltales on the Genoa. And that's really important, matching those. That's gonna tell you a lot, okay? And on the mainsail, I use the second batten from the top, and I always start off a few degrees twisted, okay, to let the boat power up. And then if you want to point higher, you tension the leech of the main. And like he said earlier, if you want to go higher to the wind, you pump your backstay up. If you have a backstay adjuster, and that straightens your head stay, okay? So to that, you know, if you have an adjustable backstay, that's really important to set the Genoa up, like we discussed. And then the leech of the main, like you said, that's where you start. And it was a beautiful job what you did of explaining that. There's finer details, of course, but great starting concepts.
And the point of tonight is to try and get the starting concepts out. What I like to have twist in the main to get the boat started. And when you get more advanced, people will talk about changing gears when you're sailing to go from pointing mode, then you tack, you need to build up speed, so you go to build up speed mode, then the crew starts going back into the pointing mode and all of these things. What I do to set the main to get started is I walk around to the back of the boat behind the backstay and I look up at it to see what the shape of the main looks like. I look at the shape of the jib and I try and match those up, and then I'm also trying to look at the boat speed and I make an adjustment and see whether the speed goes up or down. But it's
A really good thing to do, like when you're coaching and stuff, and with a lot of where y'all are at, like you get a sailmaker or a really good sailor on a boat, what they should do is they set the main up for the conditions, okay? And they say, this is what it's supposed to look like in 8 knots. And you get right where that sailmaker had that little thing, and you look at it. Okay, this is what it's supposed to look like. Then you move to the rail, and you look at it from the rail. So you look at it here, this is optimal. Then you need to get it in your mind's eye what that optimal looks like from the rail, okay? Because you're not gonna stand underneath the boom while you're racing all the time when you have 12, 14 knots of breeze. You're gonna have to look at it from the rail, okay? So that's just a little trick to expounding on what you had said earlier about in that beautiful picture we had of that shape of that sail.
yeah, so what Dave, for those of you that can't see Dave, what he's talking about is in looking at the draft distribution and the twist in the main, going to the center of the boom and looking at it in the middle of the boat when you're sailing to windward, but that's not the place you're going to be most of the time when you're racing. So now he, as a sailmaker, will come on the boat and show you how the sail should be set up for that condition. So don't just look at it there. Now move back and get on the rail and now look up at the sail and see the whole thing with it still trimmed for the optimum setting that he's put it at, I think is what you were saying.
That's exactly what, and then you do that for all the settings, and that way, I've said with almost everybody here probably, you know, I'm on your boat, I look at all the other boats, I go, ooh, I gotta talk to him. Ooh, I gotta talk. I can just go behind the boat, I can be 500 yards away in 2 seconds, 3 seconds, I got a little mental note. Because all my life, I've been doing what I just said for y'all to do. And that's how I teach the kids. That's how everybody learns, you know, that's the way. And if you just practice that in 8 knots of breathing, 15 knots of breathing, and then you get your mind's eye looking at it, you can do the same thing. It doesn't take very long at all. And then it's just I gotta adjust Cunningham, but I gotta do this. So it's just practice.
Any questions from anybody out in the Zoom world? You can send a chat in if you have any questions.
I have a question. So on the polar diagram, is that true wind?
Yes, it is true wind and it's true wind angle. And so we're not looking at apparent wind on the polar diagram. So this is the first of our series of seminars, and what we could really use is feedback from all of you about how we could do this better to suit your needs. Because we're not doing this, well, we are doing it for ourselves, for our own members and experienced people. We really want to get the people that are new to say, hey, this is something that's interesting to me. This is what I don't know. This is what I'd like to know more about. So send us comments about
You can
things
put
that
the
you
comments
like.
at the bottom of the survey.
Yeah,
as
if you've
well.
got one of the survey forms in here in the room, you can put them there. We'll try and distribute the survey forms to people who are watching from Zoom. But you can always email us or send me a question from the Facebook page. We're going to get our website back up online and running in full speed before long also. So we really need your input for things that you'd like to do. And I mentioned that we're going to try and do short quarterly cruises to work out the bugs and that sort of thing. COVID has been a big hindrance. We tried to start this program 2 years ago, but we got just completely smacked by the COVID thing. So we're trying to make it into something that is of interest to you.
Thank you, Skipper. A little applause. Well deserved applause. I have to tell you that, I mean, I've been to a lot of these seminars, and this seminar was so cool in that it got simple concepts across. And then it may have lost some of our younger folks, when we kind of went into detail, but that's okay. If you got the simple stuff, then that's all you needed to get. And those of you who are kind of new to sailing, I would tell you the same. The concepts, the simple concepts are what you need at first. But you even delivered, Skipper, for somebody like me, stuff that I maybe kind of knew, but I always forget. And so I thought this was great. If somebody wants this PowerPoint, I highly recommend it. You can email Skipper, you can email myself, and we'll get it to you, because I think it's a great content. And
Thanks.
Really, really good job, Skipper. And yes, double applause.